Good morning, Year 12s. Here's a short video on two-tailed tests. Bearing in mind one-tailed tests are where the outcome is going in a certain direction. So when a claim has been made, there's always the words increase or decrease in there, or higher or lower. However, in two-tailed tests, the word that you're looking for in the question is a difference or in a change, which means the known direction of the outcome is not known. So the notation for this, for alternative hypothesis, becomes not equal to. So the null hypothesis, let's say the probability of us throwing a dice and getting a 6 is 1 out of 6. And let's say Mrs. Core claims that the dice is biased. However, I don't know whether the dice is biased towards giving me more 6s or the other way around. So I would say, well, the probability, my claim is that the probability is no longer a 6, but I don't know which way it is. I know that there's a difference in there. If I'm testing it at a 5% significance level or a 10% significance level, what you're looking at is, if this is your distribution and these are the number of times I throw a dice, normally the significance level is either at the lower end or at the top end. However, in this case, because we're looking at a two-tailed test and we don't know which way the distribution, the specific outcomes would be, the significance level splits in half. So we distribute the significance level equally towards the lower end of the tail and towards the top end of the tail. So if it's a 10% significance level, we would split it 5% either way. If it's a 1% significance level, we would split it 0.5% either way. If we go back to our example of me throwing a dice, there's something known as the expected outcome, which is multiplying the number of trials and the probability of the outcome. So like you can see, the distribution is written as binomial NP. If I'm throwing a dice 30 times and the probability of success, which is me getting a 6, is a 6, I'm expecting to see 5 lots of 6s. So if I then do a two-tailed test, this is a little diagram to show you the rejection region and the acceptance region. What I'm trying to find out, if I'm looking at the critical region, is how many 6s I would have to obtain out of 30 at the lower end and at the top end for me to reject the null. So if I throw the dice 30 times and I get, let's say, 2 6s, that means the dice is biased against giving me a 6. And if I throw the dice 30 times and I get 18 6s, that means the dice is biased towards getting a 6.